So the first thing that I wanted to ask you about is where all these models that you have scanned for me, where do they come from and what are these objects?
Okay, so we have recently purchased the scanner. This is a quantum arm scanner. Okay, so this comes with probing as well as that is to inspect a part and also scanning. It has a 3D laser scanner. So after we purchased this part, myself and my colleague, we were trying to experiment on how the scanning tools work. So basically we have, for practice, we have used multiple objects which are available in our office, or I used to get something from outside and we started scanning to understand these things. But basically this machine will be used for inspecting whether a part is properly manufactured or not. Okay, so you scan the component and compare it with the original CAD model, whether this has been manufactured within the limits and tolerances or not. That is one application. And the other thing is the reverse engineering. And reverse engineering, as you know, if you have a legacy product, you can reverse engineer and get a CAD model of it. Okay. And then again, it is also being used for in AR/VR space, where you can just scan a handmade clay model and give it a CAD identification to it, and then you can use it in gaming or even in original AR applications for industries. This can be used for medical scanning also, for prosthetics, etc. To get exact shape of the limbs and all, and then make a 3D printed model which suits that person's leg or anything. Yeah, as an extension.
Can you tell me about each of the individual objects? Because now we have received the 3D file from you and we have 3D printed them. And
yes,
I have them here with me. Do you have the objects with you at the office?
Yes,
also?
yes.
Yeah?
Yes. I have the objects which I have sent you, the files which I have sent you.
Yeah.
Yes.
Can you represent this?
Actually, I can show you this one over here. Just see, this is a part of a scanner. You can see here.
Oh, yeah.
Right?
There it is.
So this is kind of a handle which we use for scanning.
Yeah.
We hold it and we scan.
What about this one here?
Yes. This is the mouse.
Yeah.
Here.
Yeah. We have rescaled them. They're all scaled to fit the printer. This one, I was curious, what is really this one?
Yeah. This is an object from an automobile component. Okay. So I think I need, okay.
Yeah.
Yes. Usually when we are doing reverse engineering or something, we have to disassemble the component.
This one, I really didn't understand what this was for a long time.
Yeah. So these are the coasters.
Yeah.
And you have a giant size of them. Probably you can use it on dishes. We'll be using it on cups.
Yes. That's funny.
This, of course, is from IKEA tool set.
Yes,
we just scan.
This one has still a little IKEA logo on it. Yeah, I went through the whole process of the scan and
yes,
the reverse engineering and the printing. It's still there. This, if I can show you my screen, actually, this model was the one that I used for building part of the architecture in that new exhibition.
Yes.
Yeah, so this is the hammer. You can see the mesh there.
Yes.
Then I took parts of that and I put it into here to make this exhibition architecture.
Yeah,
that's this wall here is part of the mesh from that hammer. I like this one. Oh, it's so small. Does that maybe have something to do with the polygon size on this one? Because here, this one has quite, in comparison to the other models, this one has bigger polygons.
Right, it's a different resolution with which we scan. So for practice, we have used different options available in the software and the hardware.
Yeah.
We can scan using finer resolution or a lesser resolution, which gives more point cloud and all.
Yeah.
So that is the reason you had this change in different objects. And while converting to STL also, we have some options in which we can convert it with lesser polygons or more polygons and all. We are experimenting still. So
yeah. And where does this guy come from?
It's a toy, actually. It's just a toy.
Yeah.
It is available in my house, so come as a gift with some other toy. I don't really remember.
Yeah, because I remember it from when I was a kid. I used to play Mario Kart. Can you tell me what this is?
Yeah, it has small plates. This also can be used as a coaster. Okay, but we have scanned it together. So, sorry.
No problem. This was the first model you sent me.
Yes. That's, I would say that you have done a mini size. I have a bigger size.
Oh, there it is. Yeah. The other object that I was wondering if you can tell me about is this one.
Yeah, this is, I can say, the first model that we have scanned. While we were getting trained on the on this machine, we got a person from Faro company who had scanned this model. And this lies at the entrance of our office. So I think almost you have scanned it to the same size. Okay, so this is Ganesha's idol. Ganesha is a god, Hindu god. So, and it is his idol, which we have put it in the reception of our office.
So when you sent it, the first thing that I was thinking about is it okay to reproduce these religious
it's absolutely fine.
idols?
Yes, it's absolutely fine. Usually Ganesha's idols are made of clay when we have Ganesh festival. Everybody makes them with clay, or we purchase them from market, but they are made of clay. But currently, right now, you can find them using metal, 3D printed and all.
Okay. And why do you put it at the reception?
I mean, because it is considered to be auspicious to pray to Ganesha before you start anything. That's a belief. So, like if you know, Hinduism has many gods. We pray to many gods, but Ganesha is the first god is supposed to be prayed before we start anything. So it is at the entrance.
One of the objects that were a little bit tricky, I guess, was the helmet.
Helmet, actually, we have got it scanned by my friend because that day our machine was not available. It has come out well, I can see that.
Yeah, it did come out very well.
This car also.
Yeah. Yeah, I have that. Yeah, that's.
I think it's the same size.
Yeah, pretty much the same size. I didn't take the support structures off yet, so that's what you see. The stuff at the bottom is. Yeah, can you tell me about the workflow when you go from this physical object to making a 3D model that you sell to your customer?
After we scan the component, keep it on the table here. Then we'll be having a software which will help us in accumulating all those point cloud data and convert it into STL. So before converting into STL, we'll have to clean up the data, because if you see, we are going to scan it on a table, there'll be some extra portions also which will be scanned. So all these things have to be removed and only those components have to be in the picture. And then that if any holes and all are there, they have to be closed. And then we convert it into STL.
No, because when you sometimes you sent scan raw data and there was still quite a lot of holes in it in many of the scans. That was before you had used the software for the scanner, or?
Yeah, for reverse engineering, there are dedicated softwares which we are still pursuing to purchase. So currently, the ones that we have do not fulfill that purpose, but they can be done using a CAD software. They are not. We have not used a dedicated reverse engineering software.
Yeah, so that's why they had to hold sometimes, is because you don't have the software yet to
Yes.
fix it. Okay. Are you in Hyderabad now?
Yes.
I read online that this is the technology capital of India. Is that right?
Yes. Yes. Hyderabad is like a hub to many public sector companies since a long time, like Electronics Corporation of India Limited, Bharat Heavy Electricals Limited, and many others like Hall. And also it has many defense development centers. And I mean, since many years we have been into this. And recently also from 10 to 20 years, Microsoft Development Center is here. After US, it's the only place where it has the development center. We have Google Office and all. So even the latest ones are also there. And age old, like, since after independence, India's independence, many other public sector companies are also have been set up over here.
We worked together before when you were making
Yes.
the holder video for me with a camming project. I see that you have been doing some presentations for Autodesk India and stuff like that.
Yes, actually, being an Autodesk Expert Elite member, I do some webinars and all related to Autodesk products, especially Fusion 360.
Yeah.
Previously, I used to work on freelance product design projects that I'm not doing, but for training purpose on Fusion 360, developing courses, that is still on.
Yeah, and these tutorials that you make, these Fusion tutorials that you make, they are now in this platform Udemy.
Yeah, previously they were in Udemy. Right now they are on my own website, and recently I have made some for other companies also who are into edtech, education technology companies who are offering online courses. So other than Udemy, they are available on Skillshark and Social Hardware and Codienter.
How did you learn this software and all these other softwares that you're using?
So I was into CAD designing before I took this break after my child was born. So after, when I wanted to catch up, I saw that Fusion 360 is a free tool which you can download. Instead of buying a software and learning it, I thought I should be trying this. And now I have purchased Fusion 360 after learning and also preparing tutorials and all that.
I saw that the new version has a feature that must be very useful for you. It does conversion from Polygon models to BREP, and you can have a mesh that has quite a lot of triangles, and then it turns it into a smooth vector-based BREP.
Yes, right. You're right. Yeah.
Yeah.
That is it is doing some part of reverse engineering. I think I felt that reverse engineering is very tricky because each component has its own challenges. You need to master it and you totally can get the command. It's not like one tool we are learning and we are creating an object, but each and every scan has its own, like you have to fill the hole somewhere. You have to do it. Yeah. Depending upon the complexity of the component itself, the reverse engineering process is different.
Yeah. It's a bit similar with the casting of the objects too, which is what I'm about to do now with these 3D prints. We're going to make silicon molds for all these objects and then cast them in a material called jasmonite. With this casting procedure, it's going to be really also different challenges with every object.
Yeah, different cavities, different runners, and all you need to have.
Yeah.
So which software do you use for that, for making molds?
We don't use a software. We just put silicone on it. Now we have a new positive that we can use to build a mold around. But I have previously made molds directly with Fusion. But then it is much simpler geometric shapes. I was printing these, and then we print them really, really thin. And then you can cast directly into the mold and then put a heat gun on this. And then you can start picking it off because the plastic melts a bit. So
what's that component actually?
What this object is?
Yes.
Oh, this is just it's just an abstract geometric shape that I use for a sculpture that is non-figurative. But I think for these shapes that you have been sending me, those objects are too complex to use that procedure, really. Most of them, in any case.
Yes. Thank you for bearing with us, because we ourselves were new to this technology, and we were doing and sending each of the model and taking your feedback and trying to be better with our skills.
Yeah, no, I mean, you too. Thanks for being patient with my, I don't know, strange requests.
Sure, Mamina. Yeah, have a nice day. Thank you. Just started your day.
Yeah, you too. Thanks for the talk.
Thank you.
Okay. Bye-bye.